In this video, we're going to use Faraday's law to solve for the molar mass, or the identity of an unknown substance. The problem we'll be working with here is that a student plated an unknown metal, which forms a 2+ cation, by applying 10 amps of current for 4 hours. The student recovered 43.8 grams of solid. What metal did the student recover? So, to start, we're going to write our half reaction. We don't know the identity of the metal. So we're going to just use the letter M, and it's a 2+ ion, so which means it's going to gain 2 electrons to form the solid metal. So we have a 2-to-1 mole ratio. So now we're going to go about actually solving our problem. To start, we're going to put down our 43.8 grams of whatever M is. Now, I want to get grams per mole. So that means that I need 1 mole of the metal M on the bottom of this next fraction, and I can compare that to electrons. So I'm going to use up 2 moles of electrons, 2 moles of electrons for every 1 mole of metal that I produce. Okay, so at this stage, we now don't really have anything. So we have grams of M times moles of electrons per moles of M. So we really need to get rid of that moles of electrons now. So we're going to do that by using Faraday's constant. So 1 mole of electrons carries 96,500 coulombs of charge. So again, a little bit messy still. We have grams of M per moles of M, so that's our molar mass, but that's multiplied by coulombs at this point. So our moles of electrons have canceled. So we want to get rid of that coulombs. To do that, we're going to use our current. So we have 10 coulombs per 1 second. That's our current. We're getting closer. So we have grams of the metal M per moles of the metal M times seconds. And those coulombs have canceled. And lastly, we're going to divide by time. So I'm just going to put a 1 on the top of that fraction. Now 4 hours times 3,600 seconds per hour is 14,400 seconds. And if we look here, we now have grams of the metal M per moles. So when we're trying to identify a metal, molar mass tells us what it is. For the most part, sometimes there can be a couple of options, but we'll see what we get here. So 43.9, times 0.8. My apologies there. 43.8, I'm going to clean that up a little bit. 43.8 times 2 times 96,500 divided by 10 divided by 14,400. And we get a molar mass of 58.70 grams per mole. Looking at our periodic table, this molar mass is closest to nickel. Since nickel forms a 2+ ion, I think it's safe to say that the student recovered the solid metal nickel in her experiment.